Good evening. Back with our classes on reactions of phenol. We have studied till now all preparations of phenol, manufacture of phenol by cumene process. We have even studied cleavage of OH bond, where we said that phenol reacts with sodium to form sodium phenate, and that is why phenols are acidic in nature. We also studied the reaction of phenol to form esters. Now reactions at the electrophilic center. So please write electrophilic substitution. Electrophilic substitution reactions of phenol. Electrophilic substitution reactions of phenol. Okay, so we need to start studying about why phenol gives electrophilic substitution. Please write. In phenol, the OH group donates the electron or donates the lone pair electron to the benzene ring. Donates the lone pair electron to the benzene ring, and hence the electron density on the benzene ring increases at ortho and para positions. Increases at ortho and para positions. Written, please write. This attracts the electrophile towards the ring. This attracts the electrophile towards the ring, and hence phenols are more reactive to electrophilic substitution than benzene. Hence, phenols are more reactive to electrophilic substitution than benzene. Please look here, whatever we have written, we will understand by seeing the resonance in phenol. So we have this as phenol. You know phenol has how many lone pair electrons? It has 2 lone pair electrons. We will show resonance in phenol because this will break. In the next structure, please learn to draw this, because every reaction of phenol we will use these things. There is a negative sign here, there is this and this. This is the second structure in a resonating structure. Now this negative charge moves, and what happens? This bond breaks. So the next structure we have double bond OH. As the electrons have moved away from it, it gets a positive charge, and there is a negative center here. Again this goes and this breaks. So I will have this part. Amok, can you see the structure in the end? You will have a bond here, you will have a bond here, and you will have a negative charge here. This negative charge moves and the oxygen goes back. So you get a compound like this. Can you see? I can write here. I can write here. Okay. So we will write this next step here. So we will have a compound like this, where there is single bond OH, the lone pair returns back, and you have a structure here, you have a double bond here, and a double bond here. The resonance hybrid of this is generally written as, you will have and every pi bond rotating. So you will have a negative sign here, a negative sign here, and a negative sign here. Understood? So this is called a what hybrid? Resonance hybrid. This resonance hybrid shows that the electron density is maximum at what positions? Ortho and para positions. These are the positions where the electrophile will come and attack. So benzene always gives electrophilic substitution. This is because on account of resonance in benzene, you will find the OH group sends the electron towards the benzene ring, and the electron density increases at ortho and para positions. Please draw this and write till the resonance hybrid. There should be always double-headed arrows between the resonance hybrid, between the resonating structures, and finally this is what is the resonance hybrid. Yeah, so this resonating structures proves that any electrophile will be directed towards what position? Ortho and para position. So the first reaction, nitration. Please write, this is a very important reaction of phenol. Please write, with dilute nitric acid, at low temperature, phenols yield a mixture of ortho and para nitrophenol. Yield a mixture of ortho and para nitrophenol. So this is my reaction. I take OH in presence of what nitric acid we are doing? Dilute nitric acid. At what temperature are we doing? At 298 Kelvin. I am taking 2 molecules of phenol because one get what substituted? Ortho substituted. One get para substituted. Nitration means it will have what? NO2, which place at ortho or at para. So we will have a compound which is called OH and NO2. This is ortho nitrophenol plus you get what? Para nitrophenol. Ortho nitrophenol and para nitrophenol. This reaction is considered to be very important because we get a mixture of orthonitro and para-nitrophenol and we need to separate them. So when we are separating them, we always know that this shows what bonding. This is an example of a very hydrogen. Which hydrogen bond? Intramolecular hydrogen bond. So please write ortho and para-nitrophenol can be separated by steam distillation. As orthonitrophenol shows, I am writing below it, this is orthonitrophenol. Orthonitrophenol shows what? Intramolecular hydrogen bonding. Intramolecular hydrogen bonding. Okay? As orthonitrophenol is steam volatile due to intramolecular hydrogen bonding, whereas para-nitrophenol is less volatile due to what? Due to intermolecular hydrogen bonding. Due to intermolecular hydrogen bonding. Okay? So I don't think I need to explain, but I will still one place that intramolecular part I will explain. You have an OH, you have N, you have double bond O and coordinate bond O. This is how there is a formation of hydrogen bond between H and N, and hence this is steam volatile. So it can be easily separated because it shows what? Intramolecular hydrogen bonding, whereas this shows what? Intermolecular hydrogen bonding. This we did reaction of phenol with dilute HNO3. Alright, B part. With concentrated HNO3, phenol gets converted to 2,4,6 trinitrophenol. 2,4,6 trinitrophenol, which is called what acid? Picric acid, which is called picric acid. It is a strong acid. It is a strong acid due to the presence of 3 electron withdrawing NO2 group. 3 electron withdrawing NO2 group, which help in the release of H plus ions. Which help in the release of H plus ions. Okay, so now nitration. Nitration is mainly done in presence of concentrated H2SO4 and concentrated HNO3. This is called as what mixture? Nitrating mixture. When this is done, it takes place, or electrophilic substitution takes place at ortho, para and ortho position, and this compound is called as 2,4,6 trinitrophenol, or this is called as what acid? Picric acid. Okay, this is called as 2,4,6 trinitrophenol or picric acid. Now write next, halogenation. Next heading, halogenation. This is all about nitration. Now please write the second electrophilic reaction, which is called as what? Halogenation of phenol. Halogenation of phenol. Please write phenols on treating with bromine water in presence of CHCl3. What is CHCl3? What is CHCl3? Chloroform or carbon disulfide. Bromine water in presence of CHCl3 or carbon disulfide at low temperature ortho and para-bromophenols are obtained. Ortho and para-bromophenols are obtained. Put a star and write. Bromination takes place even in the absence of Lewis acid. Bromination takes place even in the absence of Lewis acid, as the OH group is highly activating. As the OH group is highly activating. Okay, so what we studied here is, when I react this phenol, again I will take 2 molecules of phenol Generally, bromination or chlorination will take place in presence of a Lewis acid such as FeCl3 or FeBr3. It does not take place here because the OH group is a highly activating group. Now, right, B part of bromination. In presence or when phenol is treated with bromine water, it forms a white precipitate of 2,4,6-tribromophenol. And the reddish color of bromine water is discharged. This is a confirmatory test of phenol. Okay, now please, I think I have not completed this equation. I have taken two molecules, so please remove what? Two molecules of HBr, isn't it? One Br comes and one H is removed. So you will get plus 2 HBr. Now let us react. Phenol with bromine water. Phenol with bromine in presence of chloroform gives mono substitution. Phenol directly with bromine water will give what? 2,4,6-tribromophenol. This is what in color? White in color. It is a white precipitate, plus it forms 3 molecules of HBr. So how many bromine? 3. So C6H5OH plus 3Br2 gives a white precipitate of 2,4,6-tribromophenol and HBr. This is used as a confirmatory test of phenol. Now please write coal-base reaction. Very, very, very important reaction. Please write, this is a name reaction and hence it is generally asked. Please write coal-base reaction. Fine. So please write phenol, or write when sodium phenate reacts with or is heated with carbon dioxide, at 413 Kelvin under 6 to 7 atmospheric pressure, it forms sodium salicylate. Which on acidification with dilute HCl gives salicylic acid. I'll teach you the exact reaction and how it is given in the textbook also I will teach. So first thing is what? We take phenol and react it with NaOH. You will get what? C6H5ONa plus what is removed? H2O is removed. This is called as what? Sodium phenate. Fine. Now this sodium phenate This sodium phenate, when it reacts with what? Carbon dioxide at what Kelvin? 413 Kelvin at 6 to 7 atmospheric pressure, you get what? Sodium salicylate. This compound is called as what? Sodium salicylate. This sodium salicylate, when it is treated with HCl on acidification, it forms what? Salicylic acid, C6H5OH and COOH plus what is formed? NaCl. This is actually how the reaction takes place. It takes place in 3 steps. Phenol reacts with NaOH to form sodium phenate. Sodium phenate, when it reacts with carbon dioxide at 413 Kelvin and 6 to 7 atmospheric pressure, it forms what? Sodium salicylate. Sodium salicylate, when it treated with HCl, it forms salicylic acid. This is how you are supposed to learn it. Okay, but how it is given in your textbook? In your textbook, this entire step is converted as, this is sodium phenate. This sodium phenate, when it is reacted with carbon dioxide and then with HCl, it forms what? Salicylic. You can write both ways. Understood? So write both the equation. This is how it is given in the textbook, and that is how actually the reaction takes place. Please write. And what is salicylic acid also called as? 2, because this is COH is given preference. It is called 2-hydroxy benzoic acid. It is called 2-hydroxy benzoic acid or salicylic acid. Please write. Done? Written? So, Kolbe and Tachna, carbon dioxide relate with. Kolbe means carbon dioxide. Sodium phenate reacts with carbon dioxide and on further acidification forms what? Salicylic acid. Now next, write. These name reactions are very important. Please write Riemer-Tiemann reaction. Some people call it Riemer-Tiemann reaction. It is Riemer-Tiemann reaction. One of these will be 100% asked, either Kolbe's or Riemer-Tiemann reaction. Kolbe means reaction of sodium phenate with carbon dioxide. Please write Riemer-Tiemann. On treating phenol with chloroform, in presence of NaOH, a CHO group is introduced at the ortho position. To form salicyldehyde. To form salicyldehyde. SALICYL, then aldehyde, salicyldehyde. Okay, so now we will see it in different steps, this reaction. Then I will tell you how it is given in the textbook. First thing, OH. It reacts with what? NaOH. It forms what? C6H5ONA plus H2O. Please write. It forms sodium phenate and water. Write the first equation. It forms C6H5OH. When it reacts with NaOH, it forms what? C6H5ONA plus H2O. Now, this sodium phenate reacts with, what have we told? Chloroform. Chloroform can also be written as Cl, CH, Cl2. I can write chloroform like that. It is nothing but CHCl3. So now understand here, this Na and this Cl can be removed. So what will be the compound which I get?
Salt.
What will be the compound which I get?
OCHCl2.
Okay. Don't remove this because you will get confused. Let us take it as Na and take it as H. This H and this Cl can remove. So now what will I get a compound? I get ONA and I will get what? CHCl2. Correct? Plus what did I get? HCl. I have removed HCl here. Now in the third step, I am writing on the top after this. Now when this ONA and CHCl2 reacts with NaOH. How many NaOH is required to remove Cl? 2 NaOH. It forms a compound C6H5ONA and we will have CH, OH and OH. Correct? Look here. Plus what I will get? 2 NaCl. Fine. What have we studied till now? No two OH group should be attached to the same carbon atom. If it is attached, what happens? There is elimination of water molecule. So this is how it will be eliminated to form what? C6H5 ONA and there is what group attached? CHO. What is removed? Plus H2O. Understood? Now what should I do to get alcohol back? React it with HCl. So my last step will work out C6H5 ONA and CHO plus HCl will be what? C6H5 OH CHO plus NaCl. So this is what is the compound which is called what? Salicylic. Done? Now how it is given in the textbook. Stepwise understood how it happens. First thing, it reacts with NaOH to form sodium phenate. And it reacts with chloroform to form this compound. This compound when it reacts with NaOH, there is elimination of water molecule to get this compound. This compound when it is acidified with HCl gives you salicylic. Now how it is given in textbook. In your textbook, the same reaction is given as you have sodium phenate. I think it starts with phenate. Oh no. Okay. You have OH. This when it reacted with NaOH and CHCl3, then it immediately comes to the intermediate structure where you have ONA and CHCl2. This is an intermediate structure which we got in the second reaction. This, when it is further treated with what? NaOH. Isn't it? We finally reacted with what? NaOH. We will get what? Or rather one NaOH. I will get what? Fine. Actually 2 NaOH. Then what will I get? If I acidify it, I will get C6H5 OH and CHO. This is how the reaction is given in the textbook. Preferably write the way I have taught. Even this is fine because here you should not be able to understand that how we remove water. Clear till here? So this is Riemann-Tiemann reaction. Put a star and write. When carbon tetrachloride is used, in presence of, instead of chloroform, we get the final product as salicylic acid. So Riemann-Tiemann reaction, if I use chloroform, I get salicylic. If I use carbon tetrachloride, I will get what? Salicylic acid. So let us do with salicylic acid first. So we will start from C6H5OH. This reacts with what first? NaOH. It forms what? C6H5ONA. Correct? Now this reacts with what? CCl4. CCl4 can be written as CCl3. I can write. So I will get what compound? I will get a compound C6H5ONA and I will get C, Cl, Cl and Cl. Correct here? Now this, when it is treated with how many NaOH? 3 NaOH. I will get a compound what? C6H5ONA and I get C, OH, OH and OH. There will be elimination of what molecule? Water molecule. I will get a compound what is left? COOH, which on acidification with HCl will give me what? Salicylic acid. This is what? Salicylic acid. Artha. So Riemann-Tiemann reaction is of two types. When you use chloroform, you get salicylaldehyde. When you use carbon tetrachloride, you get salicylic acid. Coal-based reaction also gives salicylic acid. Riemann-Tiemann reaction also gives salicylic acid. But in Riemann-Tiemann reaction, you react sodium phenate with carbon tetrachloride, and in coal-based reaction, you react sodium phenate with carbon dioxide to get carbon tetrachloride or to get salicylic acid. Original one, if I use chloroform, I will get salicylaldehyde. If I use carbon tetrachloride, I will get salicylic acid. The next reaction, please write. Reaction of phenol with zinc dust. Reaction of phenol with zinc dust. Right? Phenol is converted to benzene on heating with zinc dust. Phenol is converted to benzene on heating with zinc dust. You have phenol, it reacts with zinc dust to form benzene. This is a very important reaction because it gives what? Parent hydrocarbon, benzene. And this is what? Phenol. Phenol on treatment with zinc dust gives you what? Benzene and zinc oxide. Now the last reaction of phenol, please write. Oxidation of phenol. Oxidation of phenol. Please write. When phenol is oxidized, with chromic acid, diketone called benzoquinone. It forms a ketone called benzoquinone. See, this is my phenol, C6H5OH, in presence of chromic acid. H2CrO4 is the formula of chromic acid. But how do we write it? We write it as Na2CrO4 plus what? H2SO4. This reacts and gives you what? You can even use Na2CrO4 or better use Na2Cr2O7. Sodium chromate and H2SO4. This forms what? It forms a diketone. This is called as benzoquinone. This is called as benzoquinone. What did I do wrong in this? I did something wrong in this structure. What did I do?
There are 5 bonds back.
So what should I do? My bonding should change. It will be like this. Okay, this is benzoquinone. Now, why is this reaction very important? See, in practicals, there is something called as organic analysis, where they may have any test tube and you will have to identify which is an alcohol and which is a phenol. So at that time, this reaction plays a very important role. Phenol generally is heated and given to you. So when you leave it in your counter for a few minutes, this phenol, the top layer of the phenol, gets into colored complexes. The color happens due to oxidation of phenol into very brightly colored benzoquinones. So phenol on standing sometimes give pinkish color, depends on how old phenol is. So it gives pinkish color, sometimes it gives reddish color. This is because of oxidation of phenol into diketones called benzoquinones. Okay, this finishes all the reactions of alcohols and phenols. What I have left for the next class is acidity of phenol and acidity of alcohol. And after that, we will start with ethers. Thank you.